Okay, so hi everyone. Today we're going to be looking at the Pahang paper 2 paper. This is a pretty interesting paper, but some quite cool questions. I think what's even more cool about this paper is that they seem to be giving all the formulas. So if you see their formula list, there's 53 formulas, which is very unlikely for the real SPM. They won't usually give more than one page. But you never know lah. Okay, you just never know how things can happen. Okay, so diagram 1 shows the black body radiation curve. Okay, sorry, I don't know why there's this D over here. Okay, it's a black body radiation curve. Now, one thing to remember the black body radiation is that theoretically, this is supposed to go this way lah. Okay, in theory, the idea is that the bigger the frequency, okay, the bigger the frequency, the bigger the intensity. Okay, but the problem is there is a catastrophe over here. We call it the ultraviolet catastrophe. Okay, catastrophe is a big problem. Okay, the catastrophe is that after a certain frequency, okay, we find that the intensity drops. Okay, and so this caused our friend Max Planck, okay, this caused our friend Max Planck to say that, oh, okay, the energy of the wave, okay, is not a continuous spectrum, but rather it is quantized. Okay, so energy is not one continuous wave, but actually it's packets of energy. Okay, so this catastrophe is the reason why Max Planck came up with this quantization of energy, which leads to quantum physics. Okay, but it all started with this ultraviolet catastrophe. Okay, so I think what is important for us to know is we need to know what is the theory and what actually happened. The theory is that the bigger the frequency, the bigger the intensity. Okay, take note, everyone, this is wavelength. So wavelength smaller means frequency bigger. Okay, so the bigger the frequency, supposed to be the bigger the intensity. That's the theory. But the ultraviolet catastrophe shows us that after a certain frequency, the intensity drops, and it's usually around the ultraviolet region. That's why it's called the ultraviolet catastrophe. Okay, so let's begin. Black bodies are the ideal what? They are the ideal absorbers and radiators, okay, of electromagnetic induction. Okay, of course they absorb a lot of electromagnetic radiation, but they also radiate. They also pancar balik lah. Okay, so don't say that it's either an absorber or radiator. Okay, dia penyerap dan juga pemancar. Secondly, name the radiation in box X. So the radiation here is between ultraviolet and infrared. Okay, between ultraviolet and infrared will be visible light. Okay, so G, X, U, V, I, M, R. Okay, so this is gamma. Okay, this is X-ray. This is ultraviolet. Okay, this is visible light. This is infrared. This is micro. And this is radio wave. Okay, GX, UV, IMR lah. Okay, yeah. If you can find a way to remember this in an easier way, go ahead and remember this. Okay, and remember that G to R is G going to R is increasing wavelength. Okay, and so the frequency will be this way. Okay, the frequency increases to the left. Okay, so gamma has a very high frequency. Okay, so the results of the experiment, experimental results involving black body radiation are inconsistent with the classical physics theory. So based on diagram 1, what was the controversy? Okay, that sparked the theory of quantum physics. So it's a pretty interesting question because they are asking you for the fakta sejarah. Okay, they're asking you for the historical facts, which is important lah. Okay, it's important, but it's not very consistent with how we are used to, physics questions. It's all application lah. Okay, so the controversy that sparked this one is that after a certain, when the wave frequency increases, okay, after visible light, okay, the intensity, okay, decreases. Okay, in theory, the intensity is supposed to increase in theory, but after they did the experiment, we find that the intensity decreased. Seperti yang ditunjukkan di sini lah. Okay, so that was the controversy. Okay, so what did Max Planck propose to solve the problem in C1? He proposed that energy of waves is quantized. Okay, you can say either is quantized or is discrete. Okay, yeah, or it's in packets lah. Okay, but the word quantum refers to that one, the packets of energy. So this was Max Planck's proposition. Okay, this was his idea to solve this problem. Don't think of waves as just up down, but think of waves as packets of energy. Okay, which we call quantums. Okay, that's why we call this quantum physics. Okay, all right. Question number 2. Diagram 2 shows a large pot with noodles being cooked in a large amount of hot water. Question: what is the meaning of heat? This is probably the most standard definition. Heat is a form of energy. Okay, don't go and say heat is something that makes something hot lah, or or heat is something that burns something no lah. Okay, heat is a form of energy. Question 2: why is this noodle being cooked in a large amount of hot water? Okay, so when we think of a large amount of hot water, we think of we think of the heat capacity lah, obviously. Okay, so water with high mass has a large heat capacity. Okay, heat capacity. Okay, so you have a lot of water. Because the mass is big, the heat capacity will be very big. Like it has a lot of heat stored inside. Okay, so the large amount of heat will be transferred, okay, to the noodles. Okay, yum, yum, yum. So of course the keywords here are large heat capacity and the transference to the noodles lah. Okay, but the idea is this lah. That's why bila kita masak mie, kan, we don't put as little water as possible. We put a lot of water because water has a very large heat capacity. It can store a lot of heat and transfer the heat to the noodles, and that's why you can cook your noodles much faster. Okay, 2 kilograms of water at 30 degrees Celsius is added to 9 kilograms of water at 95 degrees Celsius. So you have 2 kilograms at 30 degrees Celsius, dikasih tuang ke dalam, okay, 9 kilograms, okay, but at 95 degrees Celsius. Okay, so what is the final temperature of the mixture when thermal equilibrium is achieved? Okay, so let's consider situation 1. Dia akan naik suhu. Okay, so the energy in situation 1, okay, is MC theta, bukan MC delta theta lah. Okay, the mass is 2. Okay, I think it's not given here, but I'm going to give you the C of water is 4,200. Okay, the C of water is 4,200, but actually it doesn't really matter because the C is the same lah. But the delta theta, it is going to naik suhu bahkan. So it will be theta minus 30. Okay, and theta is the final temperature lah. The final temperature of the mixture is called theta. Okay, so let me leave this here for a while. Now in situation number 2, okay, this situation number 2. MC theta juga kita pakai, but the M this time is 9. The C is 4,200. Okay, and it is going to turun suhu. So it has to start from 95 dan akhir pada sini. Okay, and because we are talking about thermal equilibrium, okay, because we're talking about thermal equilibrium, therefore I can say that Q1 is equals to Q2. Okay, which means that this is equals to this. Then kamu pindah-pindah lah. Okay, you can pindah-pindah and you will get the answer theta equals to 83.18. Okay, 18 degrees Celsius. Okay, you can pindah-pindah and you get that. But this is a very common thermal equilibrium question where this in contact lah. Okay, you put the cold water into hot water or hot water into cold water. What is important over here, and I would always tell students to take some time to think about this lah. Always think about the change in temperature. Does it go, if the final temperature is higher than the starting temperature, then it's final minus starting lah. But if the final temperature is lower, like in this case, the final temperature is lower than the starting temperature, then it must be the starting temperature minus the final temperature. Because apapun, dia mesti bernilai positif. Okay, dia mesti bernilai positif. So the one that usually people struggle with is determining which one, mana satu yang tolak, mana satu lah. Okay, but if you take some time to think about it, I think it should be fine. Okay. Number 3, in a crash test, a car of mass 1,500 kg and speed 100 kilometers per hour collides with a wall as shown in diagram 3. Okay, what is the meaning of impulsive force? I think I mentioned this yesterday. Impulsive force is rate of change of momentum. Okay, just a reminder, the formula is mv minus mu per t. This is momentum. Okay, mv minus mu. mv is momentum, mu is also momentum. But mv minus mu is the change in momentum, perubahan momentum. So when you divide it by time, then it becomes rate of kadar perubahan momentum. Now explain how the crumple zone reduces the impact. Whenever we talk about impulsive force, it is usually a 2-mark question. You talk about the crumple zone increases the time of impact. Okay, that's point number 1. Point number 2, this decreases the impulsive force. Okay, whenever we talk about impulsive force, point 1 and point number 2 always come together one. Dia mungkin terbalik lah, crumple zone contohnya lah, something decrease the time of impact, and what we get because the time of impact menjadi sangat kecil lah, the impulsive force menjadi sangat besar. Okay, so either way, but whenever you explain an impulsive force question, always bring these 2 points out. Mesti kena sebut. Okay, because they come in pair lah, they have to come together. Okay, all right. C, if the car in diagram 3 stops in 15 seconds, calculate the impulsive force acting on the car. Okay, let's lay out all the information first lah. Okay, we have the mass is 1,500 kilograms. Okay, the velocity is 100 kilometers per hour. 100 kilometers per hour. We know that the initial velocity is 0. Okay, and of course here we have a time, time equals to 15. Now before you put this into the formula F equals to mv minus mu over t, we need to take note that this 100 kilometers per hour is not in the correct unit. Velocity normal unit is meters per second, makan. Okay, so always, always remember this. Okay, so shortcut lah. Okay, shortcut. If you cannot remember this, kilometer per hour. If you want to change to meter per second, if I'm not mistaken lah. Okay. Yeah. is times 5/18. Okay, kilometers per hour change to meters per second is times 5/18. Yes, I know there's a proper mathematical way, but this is kind of the shortcut. Okay, so 100 times 5/18 will give you about 27. Yeah, 27.78 meters per second. Okay, so 100 kilometers per hour change to meters per second is just times 5/18. Then you can put this into this formula and you will get the impulsive force is about -2778. Okay, -2778 newtons. Okay, why is it negative? Because if you look at the car is going towards the left. For us, towards the left usually means a negative velocity lah. So actually this is negative and this also is negative velocity because it's to the left. Okay, just something to take note of lah. Okay, -2778 newtons. But I hope that you remember how to change kilometer per hour to meters per second lah. Okay, the shortcut is just darab dengan 5/18. Meters per second change to kilometers per hour, just divide by 5/18. Okay, number 4, diagram 4 shows a few man-made satellites from various countries. Okay, wow, so many satellites. Now, what is meant by a geostationary satellite? So a geostationary satellite is a satellite that remains on the geostationary Earth orbit. Okay, the orbit, sorry, I wouldn't say remains lah. I'm so sorry. I shouldn't say remains. Okay, that orbits lah. Okay, a satellite that orbits. Dia sedang mengorbit. Okay, on the geostationary Earth orbit. That is a geostationary satellite. Okay, dia berada pada geostationary Earth orbit. So state 2 characteristics, okay, of a geostationary satellite. Geostationary satellite must follow the Earth's rotation. Okay, so orbital period, okay, masa untuk dia mengorbit satu kali okay, is 24 hours. Okay, that's one very important one lah. Okay, then the second one is position of satellite. Position of satellite lah. Okay, is always on the same geographical location. Okay, on Earth. That means dia sentiasa berada di tempat yang sama, merujuk kepada bumi lah. That means if you look up, you're always going to see the satellite there lah. Wow, see the satellite. Okay, but that's the idea. So the reason why is that is because it has to move together with the Earth. It is moving, but it's moving together with the Earth. Okay, so when the Earth spins, this also moves together. Okay, so that's the idea behind the geostationary satellite. Okay. Yes, there are more, memang ada ciri-ciri lain lah, but these are probably the most easy to remember ones lah. Orbital period is 24 hours. It's the same as 1 day. Position is always the same. Okay, same geographical location on the Earth. Now, a geostationary satellite of mass 1,200 kilograms is placed 4.23 times 10 to the power 7 from the center of the Earth. So this is probably the R lah. Okay, calculate the linear satellite, the linear speed of the satellite. Okay, linear speed, formula for linear speed is V equals to Gm over R, square root. Okay, but this M, okay, is the mass of Earth, not the mass of satellite. So be very careful with this. Okay, the linear speed of the satellite depends on the mass of the Earth and also on the distance it is from the Earth. It doesn't have anything to do with the mass of the satellite. Okay, because the mass of the satellite is too small compared to the mass of the Earth. Like it can be, diabaikan. Okay, but the mass of the Earth is the important one. Okay, and then after that, oh sorry, so please you substitute this, okay, and what you will get is about 3.07 times 10 to the power of 3 meters per second. Okay, and then secondly, the gravitational pull. The Earth's gravitational pull on a satellite will be F equals to mv squared over r. Okay, you can, if you want to, okay, you can also use F equals to gmm over r squared lah. Okay, which is I believe lah, okay, I believe either way you are going to get the same answer. Okay, you're going to get the same answer. So if you get F equals to mv squared over r, V is taken from the answer in number 1 lah, which is 3.07 times 10 to the power of 3. Okay, so if you use mv squared over r, okay, whatever your way lah, if you use fgmm over r squared or if you use mv squared over r, you're going to get the value of 267.37 newtons. Okay, that's the Earth's gravitational pull on the satellite. Okay, and actually, sorry, I also need to mention, this one is actually not the formula for Earth's gravitational pull. This is actually the formula for centripetal force. Okay, and we know that centripetal force is always towards the Earth because it is being controlled by the Earth's gravitational pull. That's why I say you can use both formulas. You can use the centripetal force formula. You can also use the gravitational force formula, okay, to calculate the Earth's gravitational pull. Okay, as long as you understand that it is because of the Earth, okay, that it is you know, it is rotating around lah. Okay, remember that this one, the mass is the satellite punya mass. Not the not the Earth punya mass. Okay, so again, this is where things get very confusing, especially for gravitation. Sekejap, this formula asks for which mass is a very important one. Okay, sometimes they will use the object punya mass, and sometimes they will use the Earth or the planet punya mass lah. Okay, but if it helps, okay, if I remember correctly, if I'm not wrong, there's only one formula where if the mass is alone, okay, like in this case the mass is alone, there's satu saja mass. In this one is easier because both the masses you have to put in. So definitely one is the mass of the Earth, one is the mass of the satellite. So you can put both in lah. But in all the formulas, the mass kalau dia adalah begini, okay, for force lah, okay, the force one, usually we're talking about the mass of the object that is orbiting, not the object that is pulling. Okay, kalau velocity, okay, sorry, kalau linear speed atau escape velocity, it depends on the mass of the Earth and not the mass of the planet. Okay, so if you have time, it may be a good idea for you to look through the formulas, see what is the similarities and what are the differences, especially in terms of the mass, because this is always a very confusing point lah. Okay, people will be like, which mass should I use? Sebab banyak pula mass dia bagikan, you don't know which mass to use. Okay. All right, so question, what happens to the satellite if the speed is lower, okay, than the orbital speed? So this is a 2-mark question. Okay, the first one will be, it definitely falls into the Earth lah. Okay, because it cannot be less than the orbital speed. Okay, if the less than the orbital speed, it will fall into the Earth or it will fall into the lower orbit. Dia akan masuk orbit yang lain. Okay. This is a 2-mark question, so I feel like it's pretty strange for it to be a 2-mark question. Because if it's a 2-mark question, they will ask what happened and then explain. But this is just what happens lah. So I guess you also have to say what are the 2 things that happen. One is it definitely falls into the Earth or goes into a lower orbit. And when a satellite goes into a lower orbit, okay, friction will cause, I think the air to burn. No, friction will cause heat, okay, on the satellite. Okay, which will cause the satellite to burn, okay, yeah, and burn the satellite. especially if the satellite is entering the Earth's atmosphere. Dia berada di dalam atmosfera, then there is friction. Okay, so friction will cause the heat on the satellite and burn the satellite as it enters the atmosphere. Okay, the atmosphere. Okay, I would say this is probably why there is a second mark. You have to mention two things that happen. Okay, when the satellite speed is lower than the orbital speed. If it is higher than the orbital speed, then the satellite will escape. Okay, sorry. If it is higher than the escape velocity, okay, then the satellite will escape. Okay, you fly off tangentially and blah, 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 blah. Okay, number 5. Yeah, sorry, number 5. So number 5, again, as I said, 5 and 6, we expect it to be soalan perbandingan dan relationship. So diagram 5.1 and 5.2 show identical copper rod placed on the bare copper wire. Once again, we see the copper rod. So if you remember from yesterday, this is left hand, Fleming's left hand. Okay, Fleming's left hand to determine the direction of the copper rod. Okay, but the problem here is I'm not really sure which is north, which is south. Not really mentioned. But okay, never mind, we'll see lah. Oh, tidak penting pula. Okay, so we see that this is the final position in diagram 5.1 and this is the final position in diagram 5.2. Okay, sorry. Okay. So when the switch is closed, the pointer of the emitter deflects and the copper rod moves to this one. Okay, so what is meant by the magnetic field? Magnetic field is a region, okay, region which experiences a magnetic force. Okay, same like electric field. Okay, electric field is a region that experiences an electric force. Okay, so pretty easy definition to remember. Of course, I remember this. Okay, now observe and compare. So the number of dry cells used, if you take a look, this is 1, 2, 3 dry cells. This is 1, 2 dry cells. So obviously 5.1, okay, is smaller than 5.2. Okay, the angle of deflection, don't need to say, you can see already. Okay, the same thing, 5.1 is less than 5.2. The final positions, okay, we would notice that the final position of 5.1 is smaller, okay, than the final position of 5.2. Okay, all also the same, 5.1 is less than 5.2, 5.2 is bigger than 5.1 lah. Okay, so name a physical quantity that causes the rod to move. Okay, actually, if you just say force, I think it's good enough lah. Okay, of course you can say force due to interaction between two magnetic fields. Oh, so long. Okay, but I think this is enough. Now relate the number of dry cells to the magnitude of the current flow. Since everything is the same, 5.1 less, 5.1 less, 5.1 less, so you know that in this case, the bigger the number of dry cells, okay, the bigger the magnitude of electric current flow. And therefore, the second one, relate the magnitude of electric current and the magnitude of the physical quantity, which is the force. Okay, I would definitely say the bigger the magnitude of the electric current, the bigger the magnitude of the force. Okay. You can say force, you can also say physical quantity stated in 5C as your answer, also no problem. Okay, but the idea is this one, the bigger the current, the bigger the force. Okay, and name the rule used to determine the direction of the movement of the this one. Now, Fleming's left hand rule. Okay, now I want to mention this. The word rule, I know it's here. You need to mention this. You cannot just say Fleming's left hand. Okay, Fleming's left hand is just a hand, but it is actually Fleming's left hand rule, which refers to this. Okay, this is Fleming's left hand rule. This is Fleming's left hand. So you have to be very clear when you answer this question. Don't write Fleming's left hand. I've seen people do this. Okay, and when I ask my friends, they say, yeah, usually the examiners won't accept if you just say hand. Okay. All right. State another way that enables the rod to be displaced further. Okay, so everything is talking about current. Okay, but we need to talk also about what else that we can do to produce a bigger movement. Okay, and of course, the most normal one is to use more magnets, because the more magnets you have, okay, the stronger the force will be lah. Either you use a more magnets or you use stronger magnet. Okay, now these are the most commonly answered ones lah. Answers. These are most common answers. Okay, talk about the magnet lah. Okay, because when you have more magnets, there's a greater magnetic field. You can push it even further lah. Okay, the interaction will be even higher. Okay, let's continue. Diagram 6.1a and diagram 6.2a shows the design of a circular wave generator machine being tested. Okay, pretty interesting. So it's a dipper, okay, and then it produces this, circular waves lah. Okay, so we see this lah. All right, now underline the correct answer. A wavefront is a line that connects all points that have the same phase. Okay, definitely the same phase. I'm not talking about the same velocity. Okay, and just to remind you, waves that are in the same phase are called coherent waves. Okay, these are names lah. Waves that are in the same phase, same frequency, same wavelength are all called coherent waves. Okay, so the depth of the water, when you compare, okay, the depth of the water looks the same lah, and it is the same. Okay, so 6.1 is the same as 6.2. The frequency of the dipper, if you look at the values, one is 90, one is 60, so 6.1 is more than 6.2. Okay, and then after that, the wavelength is always terbalik, but if not, also you can see lah. Okay, this wavelength is so much smaller than this wavelength. Okay, so 6.1 is less than 6.2. If you remember from question 1 just now, I said that wavelength and frequency are terbalik one. When the wavelength is bigger, the frequency is smaller. Okay, so relate the frequency to the wavelength. So either way also can lah. Okay, the bigger the frequency, the smaller the wavelength. You can also write it the other way around. Okay, at our level, this particular one, okay, the order is not so important. You can take both ways. Explain what will happen if the water depth in the water reservoir in 6.1a will reduce. Okay, if you reduce the depth of the water, okay, what happens is that the wavelength, okay, because explain what will happen. Oh, what will happen to what? Sorry, we have to look at the BM1. The BM1 says terangkan apakah yang berlaku kepada panjang gelombang. It's not written in the English one. What happens to the wavelength if you reduce the depth of the water? Okay, the wavelength will decrease lah. Okay, the wavelength will decrease. Okay, because the wavelength will decrease. This has something to do with refraction. Yeah, when it is shallow water, okay, so when it is shallow water, it is more dense. Okay, the density of water, okay, increases and makes the wavelength, okay, decrease. Okay, actually you can also say the speed of the wave lah. Okay, the speed of the wave also will decrease. Sorry, this is decreases. The density of the water increases, correct. The density of the water increases because the depth of the water has decreased. Okay, so in a way, you can actually say that the depth is also directly proportional to the wavelength. The smaller the depth, okay, the smaller the wavelength. The more shallow the water, the wavelength becomes smaller. Just like, the sea lah. At the middle of the sea where it's very deep, the wavelength is very big one. Then as it goes nearer and nearer to the shore, the wavelength becomes smaller. Okay, the wavelength becomes smaller. Okay, so that's a very, because the depth of the water has decreased. Okay, that causes the density of the water to increase. Okay, which is shown by this, the shallow area. Okay, so in diagram 6.3, it shows a surfer surfing a wave, wavelength of 1.5, velocity of 1.2. When it reaches a shallower area, the velocity becomes 0.6. So how do you calculate the wavelength? Now, remember that in deep and shallow area, this is obviously the phenomena of refraction. Okay, and in refraction, one thing always remains the same, which is the frequency of the wave. Okay, the frequency is constant. So if you use the equation, the velocity equals to v equals to f lambda velocity. Okay, I can say that f equals to v over lambda. So in the deep area, okay, the frequency is equals to v over lambda. V is 1.2 and the depth 1.2, and the wavelength, not the depth, the wavelength is 1.5. Okay, which will give you 0.4, I think. Sorry, 1.2 divided by 1.5, or 0.8. Okay, and this frequency is the same as in the shallow. Okay, it's the name of a song. So F equals to V over lambda. The F is 0.8. The V, okay, is 0.6. So we want to count the lambda. Okay, so 0.6 over lambda, you should get lambda equals to what? 0.75. Okay, hold on now. Yeah, okay, you should get 0.75. Then you take the same unit, okay, meters lah. So 0.75 meters. So for refraction, in this case, okay, remember for refraction, the frequency is constant, always the same. Okay, only for refraction. So that's why you can count the wavelength or the velocity in the shallow area. Okay, whether it's deep or shallow, the frequency is constant. Only the velocity changes. Question 7. Okay, shows this an electrical circuit 7.1. Okay, with 2 dry cells in the open switch state. Wow, isn't this a familiar question? Okay, 7.2 shows the switch is closed. Wow. Okay, yeah, very familiar, right? Except that in your case, there was a rheostat and one dry cell. Okay, so anyway, what is meant by 1.5 volts? Okay, that is labeled on the dry cell. What is that? Okay, that is the potential difference lah. I know it is called the potential difference, but the question is what is meant by 1.5 volts? Now, in the previous video, we talked about this lah. What is the meaning of potential difference? So I always usually say, okay, the amount of energy lah. But a lot of people will use the textbook and say the work done. Okay, you can also say work done if you want. Okay, but I would say amount of energy needed to move. Okay, to move 1 coulomb of charge. Okay, between 2 points on a circuit. Okay, dalam 1 liter lah. Okay, so yeah, amount of energy needed or amount of our work done, okay, to move 1 coulomb of charge between 2 points on a circuit. Now, based on diagram 7.1a and 7.1b and the relevant physics concept, explain why there is a difference in the ammeter reading, okay, and the voltmeter readings in the circuit. Okay, so we have to talk about 7.1. And then why is it different from 7.2? So the 7.1a and 7.1b. So this is this is this question lah kan. So we have to talk about what is the type of circuit in each one. Okay, so in 7.1a, okay, it is an open circuit. Okay, open circuit means the switch is not closed, the switch is open. Okay, so the reading of voltmeter shows the EMF of the dry cells. Okay, that is the 2 points, the first 2 points. The reading of this one shows the EMF of the dry cells. Now in 7.1b, we turn on the switch. Okay, so it is called a closed circuit. Okay. So diagram 7.1b is a closed circuit. Now when the circuit is closed, the reading of voltmeter shows the potential difference. Potential difference in the circuit, or the potential difference across the light bulb. Yeah, across the bulb. Okay. Tapi belum habis, you need to talk about ammeter also lah. Okay, so the reading of ammeter shows the current flow in the circuit. Okay. Yes, I know there are 5 points over here, but it's only 3 maximum marks lah. Okay, but I think for me the most important would probably be this point and this point, and either one of these points lah. Okay, to get the 3 marks. I feel that the reading of ammeter, yeah, like if you put it in, it's okay. If you don't put it in, it's okay. Although the question asks for ammeter, okay, but the important one actually is the voltmeter. Because in the open circuit, the voltmeter shows the position, the EMF of the dry cell. But in the closed circuit, it shows the potential difference across the bulb. So I think that's a very important this one. Okay. But I also want to give you the answer in case this is a 4-mark question. Okay, in case this is a 4-mark question, the 4th mark will be the difference in the voltage readings, okay, is due to the internal resistance of the dry cells. Okay. Okay. We are looking at the filament bulb. Okay, so we have a menthol filament bulb. Okay, and a torchlight over there. Okay, so we have different kinds of filaments. Where are the filaments? Oh, here. Okay, the filament in the bulb. Okay, okay. So the question is, you are required to investigate the characteristics of 3 filament bulbs, explain the suitability, and determine which can serve a brighter torch for use at night. Okay, this is what we want lah. Okay, so let's take this one. So tungsten or filament, tungsten or copper. Okay, this one, after a while, this gets very boring lah. Okay, so obviously you want tungsten because tungsten has high resistance. Okay, and resistance always produce heat and light. Okay, especially light lah. So we want tungsten because high resistance or high resistivity always produces heat and light. Okay. Now the filament wire, okay, whether it is a single coil filament or a coil filament. So single coil means you just take the one wire and then you coil. But the coil is you take the wire, then you coil it. Then after that, the coil itself, you coil it again, So it's like super long wire. Okay, so obviously we want the coil filament. Because a coil filament has a higher length of wire. Okay, and higher length of wire means that it is also high resistance. Okay, you can also say longer wire lah. Okay, longer wire or high resistance. Okay, so all this contributes to why the bulb or why the filament will be brighter lah. So obviously in this case, the best choice will be R. Okay, best choice is R. So yeah, I'm going to leave this answer over here lah. Nanti kau boleh check. Okay, question number 8. Cross section of the wing of an airplane Physics principle involved in the airplane. This is Bernoulli's principle. Okay, but always remember Bernoulli tidak boleh salah spelling. Okay, make sure you spell Bernoulli's name correctly. Okay, diagram 8.2 shows a jet of mass 2000 kg flying at a constant height. Okay, so calculate the lift force acting on the jet. Okay, now if it is flying at a constant height, okay, constant height means it is not going up, it is not going down. Means the forces are in equilibrium. If the forces are in equilibrium, means that the weight must be equal to the lift force. Right? So this is what it means. Constant height means equilibrium. Equilibrium. Okay, up and down, upwards and downwards punya equilibrium. So the lift force, okay, is actually equals to the weight. And we can count the weight because we know that weight equals to mass times gravity. So it's 2000 times 9.81. Okay, 2000 times 9.81. I will give you 19620 newtons. Okay, 19620 newtons. So the key word to understanding this question is the word constant height. Okay, that will give you the up-down equilibrium. Okay. Okay, question C. Based on the following aspects, give suggestions on how the jet can fly higher. So fly higher means we want a bigger lift force lah. We want a bigger lift force so that dia boleh naik ke atas dengan lebih banyak. Okay, so the angle of attack. The angle of attack refers to this one, the wing is, is it at this angle or is it at the upwards angle or is it at a straight angle? Okay, so angle of attack usually must be higher. Okay, generally, a higher angle of attack, okay, will create a bigger lift force. Okay, create a bigger lift force is definitely the angle of attack is higher. Okay, the thrust. Okay, the thrust, of course, you want it to be higher also lah. Tujahan, whether it is probably tujahan ke depan, it has to move forward even faster. Okay, so like airplane, before it can lift off, it must achieve a certain speed. Dia mesti cukup laju, baru dia akan terangkat. Okay, I think I spent quite a lot of time talking about this when we were talking about the paragliding one. Okay, but it's the same. You need to run fast enough in order for you to lift off. So the airplane is also the same. So we have a higher angle, we have a higher thrust, okay, so that the plane can move faster, okay, and also create a bigger, you can say create a bigger lift force, okay, totally no problem. Or you can say create a bigger difference in pressure. Okay, so the airplane wing is like this. If the pressure here is low, pressure here is high, then that will create the lift force upwards. Okay, so if your plane is moving even faster, the pressure difference will be even faster. This one will go even lower and this one will go even higher. So the difference in pressure is greater, which causes the lift force. Okay. Lastly, the surface area of the wing, same thing lah. Okay, bigger surface area lah. Because if you have bigger surface area, you can have more, you can have a bigger pressure down here and a lower pressure up here. So the same reason again, okay, to create a bigger lift force. Okay, to create a bigger lift force. So you notice that everything also is the same reason, create a bigger lift force, but it is relevant. Okay, it is relevant and it is correct. So don't worry about giving the same answer more than once. Okay. All right, that's the section A questions. Let's move on to section B. Okay. I think I remember discussing a similar question like this before, either in the Kelantan module, which is I don't know when, or in our class lah. Okay, but anyway, let's take a look at this. So diagram 9.1, 9.2 show a ray of light passing into glass and diamond respectively. So you're given the refractive index lah. Okay. So what is the meaning of the critical angle? Okay, so the critical angle is the angle of incidence, okay, angle of incidence in a medium with higher optical density that causes an angle of refraction of 90 degrees. Okay, causes an angle of refraction of 90 degrees. I think I mentioned this in yesterday's class. I is more than C, I is equal to C, I is less than C. But this is the definition for the critical angle. Okay, so by using the refractive index of diamond, calculate the critical angle of diamond. Formula for this is N equals to 1 over sine C. So diamond is 2.42. So you substitute 2.42 in here to find the value of sine C. And then you shift sine in order to find the angle of C lah. Okay, so you get C equals to 24.4 degrees. Okay, calculate the critical angle of diamond. And oh, they didn't ask you to this one. Okay. To show diamond is more sparkle, okay, dia lebih berkilau than glass. Okay, you are required to copy diagram 9.1 and 9.2. Based on your answer in B1, draw arrows to represent the path of ray of light after passing through point O. The critical angle of glass is 42. Okay, so in 9.1, 9.2, what happens is, this one, our angle is 30 degrees Celsius, and this is glass. Okay, the critical angle of glass is 42 degrees, according to this one. Okay, so this is a case of what? I is less than C. Our incident angle is less than the critical angle. Okay, so yesterday we said that if I is less than C, then what will happen is it will refract away from normal. Okay, so the question is, draw arrows to represent the path of that after passing through point O. Okay, point O is here. So in the case of glass, refraction will occur. Now in the case of diamond, our C is 24.4 as you calculated over here. Okay, so C is 24.4, but our I is 30 degrees. So in this case, this is I is more than C. If the incident angle is bigger than the critical angle, what will happen? Total internal reflection will happen. Okay, I think if you draw one is enough lah, but actually what will happen is you will have quite a few times lah. Okay, you will have here, and then this is this one, right? Okay, so you have here, and then you go out somewhere again lah. Okay, sorry, maybe I should draw a little bit more professionally lah. So according to the angle, it should be somewhere here lah, because this angle and this angle must be the same. Okay, so draw another one here. So you come here and draw another one here. So here, here, and then after that, finally here, it will refract out. Okay, so the total internal reflection that happens here is what causes the diamond to look very sparkly to us, yang bling bling. Okay, so kita nampak banyak pantulan, cing 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 cing, terus bling bling lah semua terkeluar. Okay, everything comes out. Right? So next one. Diagram 9.3 shows a submarine which uses a glass prism periscope to see the objects above the water surface. So with the help of the diagram, explain how the observer in 9.3 can see objects. I think I mentioned this to you before, and I think we also discussed this before. Remember that in a prism periscope, okay, how you draw the triangle is very important. So I'm going to use this guy lah. I'm going to have the periscope over here. Okay, so this is the object, and then this is the observer lah. This is his eye. Okay, so remember that when the light enters in, okay, we know that it has to enter. It has to enter like this. Okay, it must. Sorry, let me draw like this. Let me draw a bit better. Okay, so we know that the surface has to be like this. It has to be the same direction one, the surface. Okay, the only problem is how to draw the triangle of the prism. Okay, so always remember that it must be like this. Okay, the triangle shape is different because it has to enter the prism first and then reflect again. Okay, and likewise, sorry, black color lah. Here, and then reflect again. Okay, so this is where the arrows are. Okay, so the diagram itself, you know, you don't even do. I don't think you need to. Yeah, you don't even need to explain. Just draw the diagram. Okay, draw the diagram. Let me look at the scheme. Yeah, just draw the diagram. The most important thing, which everybody always seems to forget somehow, is how the prism is arranged. Macam mana prisma itu disusun. Okay, because a very common mistake that I always see lah. Okay, yang saya selalu nampak. Okay, I always see people drawing the triangle because they remember this lah. Terus dia fikir, oh, mesti dia kasih sandar pada prism, pada pada dinding. This one cannot, cannot. Okay, you cannot. This one, if it is mirror, then can lah, but this is prism. Okay, so ini memang salah. Look at the arrangement of how the prisms are arranged. Okay, you definitely, this one you cannot get it wrong. Because if the prism arrangement is wrong, the total internal reflection cannot occur. Okay, so be careful with this lah. All right, Astronomical Telescope. Okay, in our classes, I've explained this quite a number of times, so I hope you can still remember. Anyway, you are required to determine the most suitable set of lenses to construct an astronomical telescope that can produce a clear image. Okay, so of course we have to talk about the focal length of the objective lens lah. Okay, of course we want the objective lens, okay, has to be a big focal length, okay, so that we can produce, this one very standard, okay, produce real, inverted, and magnified image. Diminish, not magnified, because it has to be smaller than the sun, okay, and diminished. Okay, image. Manakala the eyepiece, has to have a small focal length. Okay, so small focal length means big power. Okay, so we want bigger power. Notice that this question, the eyepiece, they don't ask you the focal length, they give you power. You are expected to know the relationship between power and focal length. Okay, so we want a bigger power. Okay, but in this case is to produce a magnified image. Okay, it's to produce a magnified image. Yeah, okay. Because you already make the sun small. Okay, after the objective lens, the sun from so far away or the star from so far away, then you make it look very small. So you want to make it bigger so you can see it a little bit clearer, but not too big until you cannot see the whole thing. Okay, diameter of the lens, if you remember our discussion, the bigger the diameter of the lens, the more light can come in. So we definitely want a bigger diameter to get a brighter image. Okay, this is very standard. Okay, the type of lens. I mean, obviously this is convex lens lah. Okay, so we want convex lens. Okay, in this case, it will be convex lens, because the purpose of the eyepiece is to make the the objective lens punya image bigger. Okay, so to sorry, you know what? Let me write this over here, panjang. To magnify the image of the objective lens. Oh, sorry. Okay, to magnify the image of the objective lens. So when you look at it, the best choice would be J lah. Okay, so we spoke a very long time about this, about the astronomical telescope. That's why I don't really want to waste time talking about it because we already talked so much about it already. Okay, I hope that you still remember our revision session about the astronomical telescope. Remember, objective lens is to see the object, eyepiece lens is to see the eyepiece. And yes, every year I always say that telescope will come out, Hopefully this year it comes out lah. Okay, hopefully this year it comes out. Okay, question 10. Oh, that's interesting. There's no calculation question. Oh, there is a calculation question. B, done already. Okay. Question 10, NPN circuit. Okay, you have over here, this one. So name the circuit P in the transistor circuit in 10.1. Okay, so it is in 10.1, this circuit P is known as the base circuit. Okay, the base circuit, manakala this one is known as the collector emitter circuit. No, collector. Okay, CBE, yeah, collector circuit. Okay, but the base circuit is very important because the base circuit is where the base current comes from. Collector circuit is where the collector current comes from. And the working principle of transistor, a small base current can produce a big collector current. But if there is no base current, there is no collector current. Okay, I repeat once again. Small base current produce small, you change the base current a little bit, you can produce a big change in the collector current. But if there is no base current, there is no collector current. Okay, so this one, the collector current depends on the base current. It's a very important fact to remember. Okay, now when the switch is closed, the brightness of bulb X and Y is different. Okay, explain how this situation occurs. So you know in bulb X, okay, look at this one now. One is microampere, and then in the Y menthol, is a very big current. Well, big lah, although it's milliampere only. Okay, it is a very big current compared to the base current. Okay, so sorry. Okay, so point number one. This is 4-mark question so we're gonna have these 4 points lah. So in bulb X, okay, a high resistance. Okay, high resistance causes a small current to flow. Okay, and this results in bulb X lights up dimly. Okay, dia cakap brightness of bulb X is different, but they never tell you what is the brightness. So I think it's a good idea for you to put it in. Bulb X, the brightness is smaller, or the brightness is dimmer, okay, because of the high resistance that causes a small base current to flow. Okay, sorry, I'm going to add this small base current to flow. Okay, that's your 2 points. Okay, so the 3 and the 4, you talk about bulb Y. Okay, alamak, I have no space. Okay, 3. In bulb Y, okay, a large collector current, okay, flows due to the base current flowing sorry, the base current, switching on the transistor. Switching on the transistor. And so bulb Y lights up brighter. Okay. So let me repeat now. In bulb X, the high resistance which is there, okay, memang ada resistance di sini, will cause a very small current, base current to flow. So that's why bulb X lights up very dimly. Okay, but in bulb Y, because the transistor is switched on and the function of the transistor is as a current amplifier, it will amplify the current. Okay, so a large collector current will flow because the transistor sudah kena switch on by the base current. And because of that, the bulb Y will light up brighter. Okay. Okay, C. Transistor in 10.1 is replaced with a PNP transistor. Oh, sorry, B question. If the reading of the microammeter and milliammeter in 10.1 are 40 microamps and 64 milliamps respectively, determine the amplification factor. Okay, amplification factor is given by the letter beta, is given by IC over IB. Okay, the collector over the base current. Okay, but notice that the units are different. One is micro and one is milli. Micro is times 10 to the power negative 6. Milli is times 10 to the power negative 3. So make sure you change it first and then you divide it to find the amplification factor. Okay, you will get the answer of 1,600. Okay, you get the answer of 1,600. Okay, this C question. Okay, the transistor in diagram 10.1 is replaced with a PNP transistor. Okay, so draw a new transistor okay, circuit that can work normally. Now, in a new transistor circuit, okay, I'm just going to draw over the old one lah. Okay, but if we change the transistor, there are a few things that we have to change lah. Okay, firstly, okay, sorry, let me rub this off first. Okay, firstly, and the most important is that this direction must change to go upwards. Okay, so that is very important. It has to go upwards, okay, this way. That's the first one. Secondly, all the batteries have to change side. So this one will change to like this, and this one will change to negative, positive, negative, positive, negative, positive. Okay, that's one. Everything else remains the same. Okay, that's it. You change the direction of the transistor, change the direction of the cell in P, in the circuit P, and then you change the direction of the dry cell in the collector circuit. Okay, it's a very easy 3 marks. Just because you change the, sorry, it's a very easy 3 marks. Just because you change the direction of the transistor. Okay. Now there is a possibility. What if somebody asks, why do we have to change the direction of the dry cell? Is to ensure, okay, that the transistor is connected forward bias. Okay, so this is a key word. Okay, why do we have to change all this? Is to make sure that the transistor is always connected forward bias. In the original one is forward bias. Now in this modified one, we change the transistor, we change the dry cell position, it is still forward bias. Okay, so that's an important reason. Okay, the reason why we do this is to make sure that the transistor is always connected forward bias. Okay. Diagram 10.2 shows 4 electronic circuits with different specifications. You are required to determine the most suitable electronic circuit to light up 3 street lights. Okay, automatically with normal brightness when the surrounding is dark. Okay, that's what we want. So talk about the position of the LDR, connection of the batteries, the arrangement, and the use of the relay switch in the circuit. Okay, so when we talk about the LDR, okay, this one have to remember lah. Okay, you have to remember automatic switch for brightness. Okay, the LDR is connected at the base circuit, which is here. Okay, the position of the LDR is at the base circuit. Okay, why do we want it to be at the base circuit? So that it will turn on the the base current will flow when it is dark. Okay, base current will flow, okay, when it is dark. That's what we want. Okay, base current will flow when it is dark because it has a big big resistance lah. Okay, so big resistance when it is dark, so base current will flow. Okay, because it will have a big potential difference. Oh, sorry. Okay, connection of the batteries. Okay, connection of the batteries. For transistor, it's a little bit tough lah. Okay, transistor is a little bit tough. How do you explain the connection of the batteries? Okay, so you want the positive one. It has to follow this one lah. Okay, the connection of the batteries has to follow this one. The positive terminal must be connected to the collector punya kaki. Okay, so how I would write this? The connection of the batteries is the positive terminal is connected to the collector. Okay, in the transistor. Okay, can lah, you can say connected to the collector lah. Okay, and the reason for this is so that it will be the connection is forward bias. Okay, macam saya cakap tadi. Okay, so the positive terminal must be connected to the collector. Oh my goodness. Okay, they must be connected to the collector. Okay, the arrangement of the streetlight circuit. Let's take a look. Is it arranged? Oh, sorry. Let's double check. So this is the collector. Okay, so the positive is to this one. So this is correct. And this one, the positive is to the collector. So this is also correct. This is what we want. Okay, ini tidak boleh because this is the negative connected to the collector. Tidak boleh. Same with this. This is negative. Collector is here. Tak boleh. Okay. So far, Y and Z seems to be our good friend lah. Okay, except that Z also cannot already. So definitely, you know, it's Y lah. Okay. Now the street lights, are they arranged in parallel or are they arranged in series? Of course, we want to arrange them in parallel lah. Why do we arrange in parallel? Okay, for a few reasons lah. One is so that if one kalau satu rosak kan, yang lain tidak akan rosak. The rest are still functioning lah. Okay, so sorry. The bulbs, okay, bulbs are arranged in parallel arrangement. Okay, parallel arrangement. Why? Okay, when one bulb, how do you say rosak in bahasa Inggris? When one bulb breaks, spoils. Yeah, when one bulb spoils, the other bulbs can still function. Okay, there's a better word than spoils. I can't really think of the word that spoil. Bila satu bulb rosak, bulb yang lain akan berfungsi. But it's not rosak. What is the other word for spoils? Another word lah. Okay, something like that. Okay. Lastly is the use of the relay switch. Okay, do we want to use or do we not want to use? Okay, of course we want to use lah. Okay, so we use a relay switch. At this point, you know that the answer is Y already lah. Okay, memang Y jawapan kita. Okay, so relay switch is used. Okay, the purpose of the relay switch is to turn on the secondary circuit. Okay, turn on the secondary circuit. Okay, usually lah, okay, if you want to add this, if you can remember this, you add this, okay, that uses a high voltage. Okay, because in a transistor circuit, the voltage that we use is very low one, 1.5, 6 volts. But you want to turn on the street light or you want to turn on the aircon at how many volts? 240 volts. Okay, so you don't want to have everything in one circuit. Then you provide, you know how many batteries there are if you want 240. So you don't want that. Then so you have an outside circuit. You have a secondary circuit. Okay, like in this case. So when current flows over here, okay, this secondary circuit will turn on this one and it is connected to a separate thing altogether. So that's the function of yang kami panggil switch geganti lah. Okay, dia hidup bila switch itu hidup, when the relay switch is on, it will turn on the switch that is connected to a separate thing altogether. Okay, because over here the voltage is very tiny. Here the voltage is very big. You don't have everything in one circuit, like this or like this lah. Okay, everything is in one circuit. The bulbs macam mana pun tidak akan hidup tau, because the bulbs memerlukan 240 volts in order to light up. Okay, but you're only providing 6 volts. How are you going to expect to magnify it until 240 volts? So we use a relay switch for that. Okay, to turn on the secondary circuit that has its own power source of 240 volts, like in this case. Okay, so the best circuit is Y, and because of yada and yada lah. Okay, the LDR is positioned at the base. This one is connected forward bias. They use a relay switch. The bulbs are arranged in parallel. Okay, so this will be the answer for this lah. Okay, last question. Experiment is carried out to the elasticity of the compression spring. Diagram 11.1a shows the original state of the spring. Okay, original state of the compression spring. Okay, 11.1b shows, 11.1c shows the state of the same spring when you put a load of 2 newtons and 4 newtons placed on them respectively. Okay, obviously the spring akan lebih compress. Okay, so what is the meaning of elasticity? So elasticity is sifat semula jadi. Okay, it is a natural property or natural characteristic. Okay, it's a natural property of a material. Okay, to return to its original position after a load or force. Okay, after a load or force that is applied on it is removed. Yeah. So it is a sifat semula jadi sesuatu bahan, okay, untuk kembali kepada keadaan asal lah. Okay, to return to its original position. Some people say original size or original shape also can lah. Okay, after the load or the force that is applied on it is removed. Lepas kau kasih alihkan itu daya, okay, dia kembali kepada keadaan asal. That is elasticity. Okay, it's a very long definition. Yeah, okay, it's a very long definition lah. Okay, a little bit difficult to remember. So, okay, let's compare the spring constant, the force of compression, and the compression of spring X. Okay, just comparing B and C. Now the spring constant will be the same. Okay, because it's the same spring, you're not using any other one, right? Okay, now the force of compression, one is 2 newtons and one is 4 newtons lah. Okay, so obviously C is more than B lah. Okay. Yes, I know 11.1C is bigger than 11.1B, but I'm just writing for this one. Okay, and the compression of this compression of the spring, if you take a look, obviously C is also more than B lah. Okay, so C is also more than B, this one. The compression of the spring. It's quite easy comparison. Okay, now let's relate. Relate the force of compression and the compression of the spring. So the bigger the force of compression, the bigger the compression of the spring. Makin kamu letak daya, makin dia akan termampat. It's not very logical. Okay. Now make a deduction of the relationship between the compression of the spring and the energy. Okay, and the energy that is stored in the spring. Okay. So semakin besar the compression, the bigger the compression means you have more force, right? More force means you have more energy. So the bigger the compression of the spring, the bigger the energy stored in the spring. Okay, and just a side note, this one, force and compression. Okay, this is Hooke's law. Okay, the compression or the extension of a spring is directly proportional to the force applied on it. Okay, yang warna biru saja yang berkaitan dengan Hooke's law. The second one yang warna merah itu tiada kaitan. Not to say tiada kaitan lah, tapi different thing altogether. Okay, 11.2 shows a graph of compression against force. Okay, for the experiment in diagram 11.1. So based on diagram 11.2 and a suitable formula, explain how the spring constant can be determined. And the elastic potential energy in the spring can be determined. Okay, so this is X against F. Okay, now whenever you see a graph, you know that there are two very important things. Number one, okay, is obviously the gradient. Okay, when you calculate the gradient. So when you see the gradient is the y-axis is X and this one is F. Okay, so it's X over F. Okay, but formula for Hooke's law, so this one okay, a suitable formula. Hooke's law formula is F equals to Kx, and K is the spring constant. Okay, so if you flip this around, sebab saya mau gradient, but gradient is X over F, makan. So if I bring the F across and I bring the K the other side, I'll get 1 over K equals to X over F, which is 1 over K equals to M. Okay, so how would I write this answer? So by using F equals to Kx, okay, which is the Hooke's law punya formula lah. Okay, I will get the gradient, okay, is equals to X over F, which is equals to 1 over K. Okay, so you can determine the value of K from the gradient. Yang penting kamu kasih 1 over K lah. Okay, sorry, the gradient of the graph. Okay, so this is 1 mark, this is 2 marks. Okay, the next one is elastic potential energy. Okay, now elastic potential energy, the formula for elastic potential energy is 1 over 2 F times X. Okay, and in this graph, F times X, okay, F times X now will be the area underneath the graph. Okay, and if you think about it, half times F times X, right, is actually 1 over 2 times the base, this is the F, times the height, which is the area under the graph. Okay, so point number 3, use E equals to 1 over 2 Fx. And then point number 4, the area under the graph is actually half times base times the height, which is F times X, which is equals to the elastic energy. Okay, so that's how we will determine the spring constant and the elastic potential energy. Okay, by using this lah. Okay, a variation. Sometimes the graph will be a little bit weird lah. Okay, dia akan tanyakan begini tau. Dia kasih luruskan dan at the end dia sudah tiba-tiba dia jadi macam ni, dia jadi macam bengkok sikit. Okay, maybe I shouldn't like this. Let's say suddenly it becomes like this. It's no longer straight. Okay, so at this point over here, okay, the elastic limit, this part here, elastic limit is exceeded. That's why dia punya graph jadi weird sudah. Tapi selagi dia lurus, okay, dia masih mematuhi Hooke's law. It's still obeying Hooke's law. So this point here is known as the elastic limit. Okay, so the graph questions will usually ask one of these two lah. They will ask you to talk about the elastic limit. How come the shape of the graph suddenly changed? Because at that point, the elastic limit is exceeded and you don't, Hooke's law is no longer applicable. Okay. Another question is possible, which is this lah. They ask you, how do you determine the spring constant and also the elastic potential energy? So you use the gradient and also the area under the graph, okay, to determine the spring constant. Jangan juga kamu guna y-intercept. Tiada y-intercept di sini. The y-intercept is 0. Okay, so nothing to do lah. So it's either area of the graph or the gradient. Area of the graph is spring constant. Sorry, gradient is spring constant. Area of the graph is elastic energy. Okay, that is stored in the spring. So this would be our 4 sentences lah. Okay, for our 4-mark question. Okay. All right. Last question. All right, this is the last question. So the diagram in 1.3 shows a spring of suspension system of a motor. Okay. By using your knowledge of elasticity, suggest characteristics of spring which enable it to absorb shock efficiently. Okay. Explain your suggestion based on the following aspects. Let's look at how many aspects there are. There's 1, 2, physical condition. 3 is spring constant. Rate of damping of spring, 4. But you know that you need 5 marks for this. So you may have to talk about either the material or the physical condition of the spring. Okay, talk about the chiri spring. Okay, so let me give you a couple of suggestions. So number 1, the spring is made of steel spring. Okay, the material. Okay, the material, steel, or if you want, can be titanium also lah. But definitely not aluminium spring or copper. Jangan juga kamu libatkan copper and nichrome and tiada Constantan spring. No. We want it to be used in a motor. Okay, so the spring has to be tough lah. No, it has to be harder. Okay, so a steel spring, okay, is strong, okay, or won't rust easily. Okay, this will be one possible answer. Okay, another one would be we use short spring. Okay, because short spring will have a bigger spring constant. Okay, and usually bigger spring constant is always related to stiffer spring. Okay, stiffer means dia lebih susah untuk mampat lah. So it's more elastic. Okay, stiffer dia lebih keras lah. So that you don't, you don't like to sit on the motorcycle. Then if the spring is so not stiff, then you boing. What kind of motorbike ride is this? Langsung tidak shock. Okay. Number 3, you also want to use a spring with a small diameter. Okay, small diameter. When I say small diameter, means the lubang of the spring, not the wire itself. Okay, you want to have a small diameter of the spring. Okay, for the same reason juga. Bigger spring constant, stiffer. Okay, always the same one. Elasticity, always the same reason. Bigger spring constant. You want it to be more keras, bigger spring constant, bigger spring constant. So you do everything you can. Short spring, small diameter, thick spring wire, or big diameter spring wire. It means the wire of the spring yang tebal, dia tebal. Okay. Also the same reason. Bigger spring constant, stiffer spring. Okay, all this. Okay. Anything? Oh, we haven't talked about rate of damping. Okay. We haven't talked about the spring constant. Okay, kejap. Let me talk about the damping first. Okay, so the rate of damping. Okay, rate of damping means, does it damp very fast? Damping is kalau kamu ayun makan, then you let it go. Does it take a very long time to settle down? Atau adakah dia lepas kamu lompat makan keluar daripada motorbike lah, for example, lompat keluar, then the spring will faster stop. So if the rate of damping is very big, then it will faster stop. But if the rate of damping is very small, then it will take forever to stop. It just go on and on and on, and finally it will stop. So obviously we want a high rate of damping. High rate of damping means they are faster. Okay, is high. Means they are faster berhenti. Okay, so the reason for the rate of damping is high. Okay, so the amplitude of vibration, okay, reduces faster. Okay, the vibration of the spring, okay, will reduce faster. So it doesn't take so long to settle down. But this is a very, very important thing, because rate now, when we ever see the word rate now, we have to don't think faster or slower actually. We talk about rate higher or lower. But rate high means faster. Rate low means lebih lama, slower. Okay, it takes a very longer time. Okay, why is it important that the spring constant is high? Definitely we know this. Okay, so the spring constant must be high. Okay, because when the spring constant is high, how do you make the spring constant higher? You make it stiffer. Okay, so usually when we say if the characteristic is high spring constant, okay, the reason is usually stiffer. Okay, but why is it important that the spring must be keras, must be stiff? Okay, so that you will have a smaller compression. Okay, because you don't want to sit on a spring on a motor if the spring is not stiff. Like I said just now, the moment kamu termasuk lubang, bahkan terus kau akan berbounce, but you don't want that. You see, so you want it to be stiff so that you are more stable. Okay, and the way to make it stiffer is to use materials with spring constant that is high. Okay, so that when it is stiffer, you will have smaller compression. Okay, and usually things that are stiffer, smaller compression, spring constant is high, okay, can support a bigger load. Okay, dia boleh menampung benda atau orang atau objek yang lebih berat. Okay, that is heavier. Without, dia hilang dia punya kestabilan semua lah. Okay, so these are the answers for this. Okay, but I hope that, if you don't remember much about this, remember that spring constant, Hooke's law questions, the reasons are very repetitive one. Okay, balik-balik kita tengok spring constant stiffer, spring constant stiffer, spring constant stiffer. Why do we want spring constant high? So that it's stiffer. Okay, so dia balik-balik dia berulang ini. Okay, and because it's always that we want the spring constant to be high, so the spring is stiffer, and you will definitely be able to ride your motorbike in peace. Okay, kau tidak takut dia terlalu bouncy. Okay. Now, I want to mention that there is a question that came out before. Talk about the spring, but they ask for a softer spring. I think it is a question that is related to like mainan kanak-kanak. Okay, so this child's toy, so there's this bouncing palace or something like that, and it is made of springs. So if you're going to bounce around, right, obviously you want softer springs, you don't want stiffer springs. So you need a small spring constant. Okay, the spring is there to bounce you, but you want to bounce. Because bouncing is fun, like trampoline. Okay, trampoline, the spring constant is not as high as motorbike. It's high, trampoline, but it is still lower. Okay, because you want to be able to bounce. So you need to understand the question correctly. Okay, the question is, you want to absorb shock efficiently. So you don't want it to be able to bounce a lot. Okay, the less bounce, the better. So when you want to have less bounce, you need to have stiffer spring. You need to have higher spring constant springs. Okay, that's the key to understanding this. All right, that's it for our Pahang paper.